Okay, here's an example of, we talked about what happens with dimensions when you change both the radius and the height. But what happens if you only change one of the dimensions? Well, if you just change one of the dimensions, it's best to just investigate and find out what really does happen. So let's investigate with this example. It says, suppose the height of the pyramid changes to 15. How does the volume, oh, I don't know why it says pyramid. This is probably supposed to be a cone. How does the volume of the cone compare to the volume of its original? So this is the original. Let's find its volume. Hey, how do we find the volume of a cone? Well, it is 1/3 pi times radius squared times the height. We have 1/3 times pi. The radius of this cone was 9 squared times the height of 5. If we do squaring, 9 squared, 9 times 9 is 81. So we have pi times 81 times 5, and then we will divide by 3. Okay, so this is the volume of our original figure before we make any changes. Pi times 81 times 5, and then divide by 3 gives me 424.1 approximately. They want us to change the height to 15. So new problem here. Same picture, but I'm going to change the height to 15 instead of just 5. And let's find the new volume. Okay, so again, it's going to be 1/3 pi times the radius squared. The radius has not changed. They didn't want us to change the radius. They only wanted us to change the height to 15. That gives me 1/3 pi times 9 squared is 81 times 15. Let's go ahead and calculate that. 81 times 15 times pi, divide by 3. And I get a new volume of 1,272.3 about. So how does the volume of the new cone compare? To figure out what that change is or how it compares, what we do again is take the new volume, divide it by the original. And that will tell us how many times bigger our volume is. So the new volume was 1,272.3. The original was 424.1. Just go ahead and divide that. And notice we get about 3. So what is the change? It's 3 times the volume. And notice how that change came about. Our original volume, our original figure here, if I erase this, our original figure right there had a height of 5. We took that times 3, and that made our volume 3 times larger. It didn't make it 3 to the third, any of that, because height is just a single value. It's not squared or cubed in the formula. Okay, so let's try that again, but this time let's change our height to 10 centimeters. So let me go back and see what our original volume is so we don't have to calculate that all over again. So we're using the same figure, so our original volume is still going to be 424.1. Okay, now let's find the new volume. So they want us to change our height to 10 instead. Calculate the volume again. Okay, so this time we have 1/3 pi times our radius of 10 squared times, 9 squared times the height of 10. Okay, go ahead and calculate that. That would be 1/3 pi. 9 times 9 is 81 times 10. Okay, and again, this is our new volume we're calculating here. So we're taking pi times 81 times 10, and we get, and then divide by 3, and we get 848.2. All right, what was the effect? Well, to calculate how many times larger the volume got, we take the new volume and we divide it by the original, and that will tell us how many times larger we have. So our new was 848.2, our original was 424.1, and if we divide those, we get 2. So what was the effect? The volume is 2 times the original. Notice this doesn't follow our patterns we had because we are only changing one of the dimensions and we're not changing both of them.